All right, I think we will get started. Thank you everyone for coming on this, this Tuesday morning. It's rainy where I am. I hope it's nice where you are. My name is Jennifer Abel and I am the training coordinator for the Portage network. And I'd like to acknowledge that I'm speaking to you from the traditional, ancestral, and unceded territory of the Coast Salish people, including the territories of the Musqueam, the Squamish, and the Tsleil-Waututh. And we are here today for a presentation from Ocean Networks Canada on what are we doing about dynamic data. In this webinar, Ocean Networks Canada invites you to learn about their approach to citing dynamic and heterogeneous data sets. They leverage advances from the research data management community, such as Research Data Alliance Data Citation Working Group's recommendations, the Research Organization, or ROR emergence, ROR integration with the DataCite schema, and revised Earth Sciences Information Partners citation guidelines. Even so, there were conceptual, technical, and sustainability barriers to overcome. To allow users to cite the exact dataset subset and version, we refactored our infrastructure and curation processes to handle query details and versioning provenance. Substantial effort went into supporting geospatial extents for fixed position, mobile, and remote sensing instruments. These improvements are represented in landing pages, web services, and documentation. While manual intervention remains for curatorial reasons, the vast majority of our implementation is automated. We hope our experience assists other repositories in plans to meet fair and trust principles. And the work that they're going to be talking about was funded by CANARIE. A few housekeeping things before we get started in earnest. You have been muted automatically when you entered the room. This webinar is being recorded and the chat may be archived for those who are unable to attend. We encourage you to use the latest version of Zoom so that you have access to all of the features, including security updates. Please use the chat feature if you're having technical difficulties or have additional resources to share. And please use the Q&A option to ask questions of the presenters. Questions will be addressed at the end. You can wish to ask a question. Questions may be asked in English or French, but I'm guessing they will probably be answered in English. But if I'm wrong, you can let me know. You can find the complete code of conduct that we follow in these webinars at the web address on your screen and soon in the chat. Carl and the Portage Network are committed to providing a welcoming, safe, and harassment-free environment for its staff, membership, committees, and working groups, as well as for participants, speakers, and organizers of Carl meetings and events. We do not tolerate harassment of any kind. Our speakers today: Raina Jenkins is the Data Stewardship Manager at Ocean Networks Canada. She's been closely involved in metadata management, data acquisition, expedition support, and interoperability initiatives at ONC for more than a decade. She is active within the research data management community through working groups and committees, including as a board member for the Core Trust Seal. Chantal Ridsdale is a data steward at Ocean Networks Canada. She works on data management best practices, processes, procedures, policies, and standards for various projects and programs at ONC. She's a busy woman. Additionally, she maintains instruments and expedition metadata and data records for reuse in Oceans 2.0. And Melissa Cuthill is a data steward at Ocean Networks Canada. With an academic background in psychology and library and information studies, her interests converge in a conviction about the importance of research data management to scientific reproducibility, which she will lecture you about ad nauseum at this latest opportunity. She works to ensure ONC's voluminous data is described well enough for users to find, understand, and be able to reuse it. And now, ONC team, the virtual floor is yours.
Thank you. I'll just wait for the slides to come up, and thank you for that wonderful introduction for us. And I also do want to acknowledge that we had a whole team involved in this effort. In particular, I want to highlight Jessica Robinson, our project manager, and Melissa MacArthur, our senior developer. And you'll notice that we make sure to include our RORs and ORCIDs, as this is all about what are we doing at dynamic data at Ocean Networks Canada. So we make sure we have our identifiers wherever we can. Next slide. So not everyone here might know about Ocean Networks Canada today. So just to give you a little bit of an introduction, Ocean Networks Canada is a ocean data both operator of ocean observatories and platforms, and as a repository for our own data, but as well as third parties that we've been interacting with. So this is data that's on all the coasts of Canada, mainly, well, the vast majority of our data does come from the West Coast in the Pacific, but we are also supporting instrumentation and platform in the Atlantic side and in the Arctic, as well as some third parties that are a little bit more international in scope. So quite a bit of breadth. And in this map, you can see some of our infrastructure in the southern part of BC, just to get an idea of the complexity of the different data systems that we're dealing with. So we have our cabled networks in the Pacific Ocean and in the Strait of Georgia and in Saanich Inlet. These are Neptune and Venus arrays, as well as we have smaller observatories, community observatories along the coasts. We have earthquake early warning systems on land and underwater. We have ferries, we have radar systems. We have all kinds of these data, so it's very heterogeneous. Some of them are coming in live, some of them are autonomous, some of them or sort of in some kind of delayed mode. So all kinds of situations that we're dealing with. Over 400 instrument types and all kinds of different data formats and processing that we need to handle. So super dynamic as well. So we have these accumulating data streams where data is coming in and appending on the existing data set over time, as well as we do have to version the data due to whatever errors we might have to fix, and or just to extend sometimes the capabilities of a data set in the past. So next slide. So just to set the stage a little bit about leading up to this project, all these community efforts that kind of helped us out. So first of all, ONC joined the World Data System in 2014, and many of you would know that this became following the certification processes of the Portage seal a few years ago as they merged the requirements with the data seal of approval. So in the Portage seal requirements, there's requirement number 13, which is about data discovery and identification, meaning you have to apply persistent identifiers to your data sets. So this is something that we hadn't been doing, and this is something, of course, we need to do if we wanted to maintain our status of being a certified repository. And then, of course, the FAIR principles came out. And in that, you, of course, see this notion of the identifiers and all the great benefits that they give. And then COPDUS, the Coalition for Publishing Data in the Earth and Space Scientists, they put a commitment statement. So we know now that the journals, all the other kinds of publishers, they're going to be starting to pay attention to this and requiring that of their researchers. So we know that we need to get on board and we become a signatory. And then finally, also, we begin to get some funding coming along in this direction with CANARIE funding the research data management starting in 2018, where we were awarded a project to implement these data citations. So this project is called Minted, Making Identifiers Necessary for Tracking Evolving Data. Next slide. And then one thing that we really leveraged throughout this effort was the Data Citations Working Group guidelines within the Research Data Alliance. So they had already thought about these problems of dynamic data, data that's changing over time, how to more appropriately acknowledge the specific subsets that a researcher is using in their research, and also to take account of any versioning that happens. So these problems were already kind of outlined, and so we could follow these guidelines. And so there's 14 recommendations, and you'll see these just listed at the bottom, but there's quite a lot about this concept of a query store, which we'll learn about as we go on in this presentation, about the versioning, your landing pages, thinking about just sustainability of the system. So all of these will come into play, and you'll see how we implement them throughout the presentation today. Next slide. And then I'm just reiterating the importance of the FAIR data principles are here with the persistent identifiers, of course, being important for the findability. Even if that data is no longer accessible, like because of versioning and we don't have the older version in some cases, we still make sure the metadata is available. And then of course, with the versioning, you get the provenance information to assist with any kind of reproducibility reusability. So definitely the work that we do help us to attain a number of these criteria. Next slide. Now, when we originally started our project, we were thinking about ORCIDs, but then as our project was underway, there was the emergence of ROR. And so that was actually a better fit for us because in our institution, we typically deal with third-party organizations. And so this was more in line with the agreements that we already had in place. And so we had this change in our project to implement RORs instead of ORCIDs, although ORCIDs is something we'd like to come back to. So as ROR emerged, it's already got a lot of organizations in the system. We decided to take advantage of that. Next slide. And then, although this is not necessary for our project, certainly comes into play more and more as now we're starting to talk about the trust principles. I think many of you probably did attend the symposium last week with Research Data Canada on the and also co-hosted with Portage on the trust principles. So I don't need to get into detail here, but of course what we're doing is helping us deliver on these trust principles as well. Next slide. So getting more into the specifics about the Minted project. So first of all, we're trying to support these dynamic data citations following the RDA guidelines. We're also wanting to improve the provenance, the versioning, and also our metadata records for these data sets. We knew we wanted to use DataCite for minting and to implement the RORs. And then also we needed to deliver services. So this was not only a requirement of the CANARIE project, of the CANARIE funding, but also it comes up within the RDA guidelines. And so basically to apply these DOIs, we had to really think about a number of things such as dataset granularity and how do we make this sustainable over the long term. At ONC, we're really dealing with a culture that's agile and innovative, and how do we have persistent entities in that kind of environment was a challenge to try and think of a way that we can ensure that our choices will last and not, not be succumbed by the dynamic environment of research data management that we're in. Next slide. And then, so here was our system architecture design right from the beginning, and now we have this achieved. But basically this blue area represents Oceans 2.0, which is our digital architecture. And so inside of that, you have our database. This is both our Postgres, where our metadata resides, our Cassandra database, where our data resides. We have a file archive directory, and we have this ISO metadata catalog. We already had the data search interfaces and data discovery APIs and also data access through ERDAP, but here now we're adding on the landing page for the citations. And you can see in the orange, that's sort of external relationships that we have. So we're communicating using the ROR identifiers, using DataCite for the registry of our data sets. And then the idea is that scientists, of course, will download the data, they'll cite the data properly, publish, and then that publication will, with the PID graph, we'll have all these linkages between the RORs, the journal articles, and the data sets. And then, of course, we're dealing with third parties, so we'll have those data partner data sets entering and being properly attributed. And then harvesters could, of course, harvest the catalog and do whatever they do. So I think that's the end of my slides, and I'll pass it on to Chantal.
Thanks, Raina. So there are several things we needed to consider granularity-wise in our definition of a data set in Minted, whether it would be by time, by geography, by instrument type, by platform, by data product level. So it took quite a lot of effort to figure out what worked best. We then had to consider the various external constraints, such as how to map our internal infrastructure to the DataCite metadata kernel properties, identify how our internal infrastructure already met the RDA guidelines, what could be leveraged with minimal additional effort, and what needed to be implemented from scratch. The suitability of ONC's data architecture, how we would apply data partner attributions and credit properly through the system, and how the end users would interact with the end product. Lastly, we were aware of the RDA dataset granularity working group, or the potentially new, who just presented their birds of a feather at RDA Plenary 16 and are in the process of developing a case statement to submit to RDA to become a working group. They intend to address issues such as community conventions for interoperability, existing approaches and terminology interpretations, impacts on discovery, access, citation, and more, and how these interact together. The work that this group will undertake will affect this project, and so we are dialed in to learn of the progress going forward with an ONC representative as a member of this group. So what is a data set? It's not as easy to define as you might think by instrument, by site, by time frame. We just went over that, but in our context for ONC, it's one deployment of one device. So from when it's placed on its site and connected to the network to when it's disconnected and recovered from that site, looking like the image on the right. Not always, but it's usually pretty interesting. So after we defined what a data set was, we needed to consider how and when to mint a DOI for a data set. There were several questions we had to consider through this process as well. How soon after an instrument is deployed and data is streaming, how to automate, ensuring all required metadata is in the database and deemed correct, manual or automated integration into our instrument workflows, wait until a query exists in the query store, mass or batch minting of existing data sets and repository, data steward peer reviews, quality assessments are complete. So there's a lot to consider. In the end, we decided that an automated daily scheduled job to check if there were any new devices affected by new deployments would be the best. The job identifies whether the minimum metadata is populated in the database. Minimum metadata consists of a combination of DataCite kernel required fields and optional fields that ONC is deemed necessary to add value to the record. Any changes will be accounted for in versioning. So in the automated process, ONC defines job parameters, a few as required, and the job will then grab all relevant deployments for the device types and publish the record to the production environment if the minimum metadata exists in our system, including if data files are archived, geospatial coordinates are entered, data products are assigned, and so on. An ONC data steward then monitors the automated job to ensure that it completed correctly. So I'm going to highlight the challenges of implementation and automation of minted abstracts. So manually adding abstracts for all the records in our repository is not a sustainable solution, and so ONC spent significant time identifying what was required and how we could further leverage our existing infrastructure to automatically construct abstracts and what needed to be included and did not already exist in our system. So device name and the top right here is how it's constructed. And then the example is color-coded on how it's actually renders. So the device name and site device date from were already used as it existed initially, but fields such as the search tree node name, the descriptions, device category names, and descriptions, they existed but required some finessing like spelling out acronyms, building more robust descriptions, identifying what locations and sites were appropriate, because ONC uses some internal verbiage such as like the Venus instrument platform. People outside of Ocean Networks Canada who aren't familiar with our infrastructure already might not be familiar with that being a location. And so we needed to create flags that would identify appropriate level to include. So when jobs are run automatically, there are chances that errors might not register and DOI is minted anyway, but the metadata entered is not completely correct. ONC uses the device workflows to track the work completed pre-deployment, during the deployment and commissioning after connection for the deployments. One of the tasks in the commissioning phase is a deployment includes data citation verify, where they confirm the metadata populated is correct, and if there are any issues with population, then they can update the metadata, only the metadata without minting a new DOI, and this would be recognized in the metadata version. Pass it over.
Great. So now I'm going to talk a little bit about the major outcomes of all of these processes that we've discussed, DOIs and landing pages. Everyone here who's involved in RDM is probably familiar with the many benefits of Pids, particularly for data sets. ONC prior to Minted did not have a very robust system for getting people to cite our data. We had this excerpt from the website saying, you know, if there's an option of a data citation, it would be great if you would construct one yourself as the user, which, as we know, the best way to get someone to do something is to make it easy for them. So the Minted project has now made it easy for people to cite our data. They don't have to construct a citation on their own. We just hand them a nice DOI that'll take them to a landing page that's full of metadata. And next slide, please. So this is a landing page. This is sort of an archetypal landing page. These live in our Oceans 2.0 data management system. This is for a fixed position device. As Raina mentioned, we have a variety of devices that some are fixed, some move around, some sense data from places other than where they're situated. But the fixed position device is by far the most common. So this is an overview of what the landing page looks like. And if you can go to the next slide, because that's hard to read, I just wanted to zoom in on the pieces of information that you get. So when you enter a DOI into this landing page resolver, this is the information that you get. You see the title and the abstract there. The abstract is, as Chantal explained earlier, dynamically created from a template. It's the same with the title. And there we have the DOI, of course. Next slide. Any creators of the data set, those would be people who own the data or data products. In this case, this data is wholly owned by ONC, but if there were multiple owners, we do have data partnerships and data agreements. So if there are multiple owners, they will appear there in a list. We have the date that the data set was created. That's the date that it was ingested into our database, not necessarily the date that the data was gathered by the instrument, because we do have instruments that are autonomous and they have to be collected and the data ingested manually. We have this section for funding references, which is a bit aspirational just because ONC has a very complicated funding structure where a repository that also generates its own data. We have a number of different projects. So we have our major funders for, ONC, we have match funding from all kinds of different sources, and that changes year by year. So we basically put the structure in place in the future to show funding references, but for now it's a little complicated. And then we have the publisher, which is ONC, that's always us, and the publication year, which is the year of the date created. Next slide. Then resource type and rights are just boilerplate statements about this being one deployment of one device and directing the user to our data policy page, which is currently evolving in response to this project having been completed. Then you can see all of the formats that the data is available for download in. And then geolocations, dealing with the geolocations was one of our sort of major challenges, especially in automating this process, because we have, again, some instruments like this one that are fixed. So it has a nice, neat geolocation point. It has a lat and long, but we'll look at a couple examples later for mobile devices and remote sensing devices where those are more complicated and we had to be able to accommodate all of those situations in our metadata. And then we have various types of contributors. This is roles according to the DataCite metadata kernel for distributor and data manager. Currently, those are usually us, but you never know in the future. Next slide. And then finally, on the landing page, you have the citation, which is beautifully formatted for cutting and pasting by the user. They are formatted according to the ESIP guidelines, ESIP being the Earth Science Information Partners, according to their publication Data Citation Guidelines for Earth Science Data, version 2, which is the standard because we are an Earth Sciences focused organization. And then we have links. You have a link to download the data again via our data search interface on Oceans 2.0. There's another link to Oceans 2.0's entry for the particular instrument that was used for gathering the data. We have a lot of information about the instruments on there beyond what's, in a landing page. And then you can also download a full ISO 19115 XML metadata record for the dataset, which is much, much more extensive than what you see on the landing page. And finally, on the landing page, you have the version history, because we do have to deal with a lot of versioning of instruments. If a dataset is versioned, you will see the DOIs for all of the versions here. Whoever versioned the data set will have given a reason why it had to be versioned and the date when it happened. So this shows the provenance of the data set, how it's evolved, and helps people find the data that they used historically. Next slide. And this is just an image of the metadata record for that same data set in DataCite Fabrica. That's their tool for managing your DOIs as a DOI creator. This is also the record that would appear in their search portal. And it more or less has the same information as on the landing page. The landing page just has a couple of extra sort of local pieces of information. And you can download this metadata record in your choice of formats. And if there's any versioning of the metadata, it's reflected on this page as well. And you also have your citation there again for easy use. So next page, please. Now we've talked about some of the challenges involved in having such a diverse network of instruments and types of data coming in. So to support both the DataCite metadata kernel and the more extensive ISO requirements, especially for automatically generated records, we had to do some work under the hood at ONC with what metadata we stored, where we stored it, and how we stored it. And so for the next bit of the presentation, we're going to talk about those sort of non-standard kind of cases, or the more difficult things that we had to implement, such as the different geospatial metadata cases, different data attribution cases. Like I said, we have a number of data partners that have shared responsibility for our data sets, and including their party identifiers, ROR, and hopefully soon ORCID. And also data subsets, because of course, to ensure reproducibility, we need to know exactly what subset of data was used. And then we also have the Oceans 2.0 API, which already existed and supports a number of different functions, but we wanted to add the DOIs and query Pids to that for citations and metadata records. And finally, versioning, perhaps the biggest challenge of all, how to support that in the metadata and integrate it with all of the automation. So next slide, please. With the geospatial cases, the landing page I showed you before was for a fixed position instrument. It goes down to the ocean floor, it doesn't move, it streams data through our network in real time, and the data set ends essentially when we pull it up out of the ocean. For mobile devices, they have this awkward habit of moving around. For instance, we have a lot of devices mounted on the ferries, such as this thermoselenograph. And for those, we needed to implement basically a bounding box in the geolocations instead of a geolocation point. So we have basically the northernmost, southernmost, easternmost, and westernmost Latin long points to define a box within which the data has been gathered. And you can see that corresponds to where the path of the actual instrument on the ferry in these maps that you can also download from our data downloads. More and more repositories and data search portals are leveraging geospatial metadata, particularly to support map-based searching. So we needed to make sure that this kind of geospatial metadata was robust, so it can be integrated with that. Shout out to Geodesy at UBC. Next slide, please. And our other geospatial case is for remote sensing devices, and we had to do some real work under the hood for this one, because previously ONC had only captured for the geospatial metadata the physical location of the instrument. But for something like a radar that is sensing an area broader than its own location on the ocean floor, we needed to do some work to make that capturable. So we had to implement this geographic extent sort of framework in our data model in our UI for remote sensing instruments, and develop procedures for calculating and populating the geographic extent for these instruments, some acoustic instruments as well as radar and some others. So in the end, what you would get on the landing page for these is a geolocation polygon, kind of like a bounding box, but with lots and lots of different points, as in the images below, so that would sort of delineate that area where the data was collected. Next slide, please. So another important thing at ONC is our data partners and the data agreements we have with them. And the DataCite metadata kernel pretty recently implemented support for RORs in August 2019. There was some support previously from the 4.0 and 4.1 schemas for delineating for the creator and contributor names. You could have a name identifier that was either personal or organizational. That was introduced in 4.0. And then the support for affiliation identifiers was established for the affiliations in kernel 4.3. So that allowed us to bring in the URIs and the scheme type to directly link to the ROR entries in our metadata. ROR was also added as an option for the subproperty in funding reference. Although publisher still isn't supported, but we're going to be working on that in the future. We obviously think that's important since we're publishers. Next slide. And this is how the RORs were implemented. So there's an image of the landing page again, and you'll notice under creators, we have 2 entries. This is for a project that ONC has done in partnership with Defense Research and Development Canada. We put an observatory up in Gascoyne Inlet, which is up in Nunavut. And it was designed and installed in partnership with the DRDC, so we co-own the data. And the DRDC happened to have a ROR. So if you're on the landing page, you can click on an organization, and if it has a ROR, it will take you to that ROR's entry on the roar.org page. And their name is also included in the citation for this data. Next slide. Now, kind of going up the scale on challenging for unusual cases, data subsets. So what if you don't need the entire data set? Research has indicated that usually people who are reusing data don't use the whole data set, they're using some subset of it. And so for reproducibility, clearly that can be a problem. If they publish down the line and they're just citing, here is an entire data set, and they only used a little piece of it, that's going to make it difficult to reproduce. So to work on this, we followed the recommendations of the RDA Dynamic Data Citations Working Group guidelines that were published in 2016, identification of reproducible subsets for data citation, sharing, and reuse. Reina mentioned this earlier. There are 14 guidelines, but I've picked out the 4 here that are most relevant to this particular problem. For data subsets, you are looking at dealing with queries and the query store. So the organization should provide a means for storing queries. In our case, it's searches through data search and their associated metadata. The queries should be time-stamped, obviously, because if data is being versioned over time, you need to know exactly when that data was downloaded to know which version it is. And then each query should be assigned its own individual unique query PID. the query PID it's recommended that it be local rather than using, say, a DOI, because if we're assigning DOIs to every search that everyone ever runs on a database, we're like quickly going to outnumber the number of atoms in the universe. And finally, the query has to be stored, permanently over time. So next slide, please. And this is what I call the pie model of query PIDs, whereas a DOI represents the entire pie, where the pie is the data set. The query PIDs are all the different ways that a user might slice it up for their use. So in Oceans 2.0, every data search or query is saved in our database and labeled with its own local identifier, which we're calling the query PID. And the query PIDs can be used just like a DOI in the Oceans 2.0 landing page resolver to view a landing page. And you'll see the landing page for the full data set, but then there's an additional section with more information about the query. Next slide, please. For those of you who haven't used our system, this is our data search interface. So if a user is searching for a data set, we're not like a database like Dataverse, where the data set is all nicely packaged up as a complete zip and you just download that and you're good to go. We're kind of lucky in implementing the query PIDs in that Ocean Networks Canada's database. Our search was already set up to provide data in these little individually defined slices. So it wasn't that difficult to apply the query PID sort of structure over top of that. We already had the query PIDs and were storing them for the searches. We just needed to foreground that. So here someone has searched for data. They're looking at fluorometers and they've narrowed down to this particular deployment at Barkley Canyon in 2019. And once they select that, that black box pops up and that will take them to where they select their particular parameters for download. Next slide. And this is where that button takes them. There's a lot of information here, but basically these are all your choices you can make. You can define the date from, the date to, so the date range of the data that you want to download. We have all kinds of different file types and different data types, scalar data, scalar plots, log files, some's QA, QC, some isn't. And these boxes show, this is a device that has two different types of sensors, a chlorophyll and a turbidity sensor. And maybe you don't want both of those. Maybe you only want one of them. You're only interested in chlorophyll data. So you would, check that. In this case, we've chosen just a one-day piece of the data set and CSV file, all of the sensors. And then down at the bottom, you have some other options about ways that the data has been processed and data gaps have been filled. So the user would then add that to their cart and they would download it. And at that point, they receive the query PID, and the query PID is stored in our ONC database. So next slide. And this would be the landing page that you would get if you use the query PID. In this case, you see the query PID up there at the top, like 8510415. So you've got all of the data, all of the metadata that you would have for the DOI. It says it's, a Barkley Canyon fluorometer. It was deployed at this time, blah, blah, blah. But then you also have this extra section, query details. And if you were to compare these query details with that last slide, these match all of the options that the user selected during that process. The type of data that when the query was created, that's when the query was first run. The date from and date to, you see it's that one-day time range we chose. All the variables, it was in CSV format. So this makes it really easy to go back and recreate that search, as opposed to if you just had the DOI, didn't know any of this information, you wouldn't know what parameters to choose. And then finally, down there at the bottom, you see the query is included in the data citation, and we also have a date for when the information was accessed. So that is the work on data subsets. And if we go to the next slide, both the DOIs and the query PIDs can be used with the Oceans 2.0 API to retrieve either a data citation, again, according to the ESIP guidelines, or a data citation and the full metadata record by way of a secondary call onto DataCite's API. So you can get the full DataCite metadata record by way of our API in that way. And so these are just two calls that were made on the API, one for a DOI, one for a query PID. They're using a simple get method. And these are the results that you would have. So the final piece to talk about for our crazy unusual cases is versioning data, and Raina is going to take it from there.
Right. So as Melissa mentioned, this is probably one of our most challenging aspects of the project. And so I'll go through this, try to do it carefully. So we kind of came up with this idea of this batch system, where the batch describes all the pieces that we need to encapsulate what's involved in the versioning. So basically we decided that there's triggers. So right now we're supporting metadata triggers. So basically something has to change in order for versioning to occur. So right now we're supporting metadata changes, such as if we needed to change a formula, if we needed to change a parameter on the processing of a visualization, or if we needed to alter our parsers. So anything that we need to change the metadata on is currently supported as a trigger, and it would be stored as part of that batch. And then basically then you have to do the actual execution of the versioning. So whether it's reprocessing or rederivation of products or whatever it happens to be. And then you actually then again have to create a new DOI and associate the old and the new DOI together. So that's basically the ingredients of the batch. And yeah, like I mentioned, some examples of triggers. And when we go through the process of the metadata changes, the algorithm is automatically determining which data sets are affected by those changes and enrolling them into the batch for the ones that would need a DOI update. And currently, the kinds of versioning that the system can handle is, like I said, if we're reprocessing. So for us, reprocessing means we have to reparse the data from the rawest form. So this might be because we have a formula fix, or maybe the parser was wrong in the first place. We also have this concept of repost-processing for derived data products like visualizations. And also if we needed to upload new files to fill in a gap or something was weird about the original files, corruption or something, we can do that as well. So we've developed a workflow with our data stewards for when we're doing this, that it incorporates this new process. It's quite a bit of a change to the team that we're kind of rolling out carefully with the different use cases and trying to get all these different use cases documented. So it's a bit of a process, but we're going through it. Next slide, please. So with the versioning of the data, I just want to point out this aspect of the DataCite kernel. So there's the related identifier field, which allows you to establish relationships between identifiers. So here we have the snippets of is previous version of, is new version of. And so when at the end of that batch process, it will amend the XML for each data set to have one of the two, whichever one makes sense. As well, on our landing page section in the version history, you'll now see a list of whichever DOIs are appropriate, and the highlighted one will be the one that you've resolved, and then you can easily click to the other one. Whenever you create a batch, you also stipulate a reason. So this is just a text field that data steward would enter. It's a high-level reason, but then there's details. If the metadata triggers, there's this down arrow on the left of that version history that would give those metadata trigger details. There's still more we'd like to add there to communicate to the end user, but this is definitely an important start. Next slide. So this is just an example of doing versioning of reprocessing. So we have this one situation where we had a working parser, but for some reason we had some issues with the QA/QC automated system, and we had to kind of stop that parsing activity until we could rectify that software issue. So then we had this gap. It wasn't a real gap because we still had the raw data, but we just weren't parsing it. So we had to come back and reprocess that after the release of that code. So we have a JIRA ticket to do the fix. JIRA is our ticket tracking system that we used. And now this has to be done. And so next slide. So a batch gets set up, and the reason is described. And so there's this concept of the trigger. Now in this case, the trigger is a code change. So actually we're not capturing that quite properly yet. But we do have the JIRA ticket as part of our metadata about the batch. So it's traceable about the reason internally, and later we can hopefully capture the code changes within the batch more directly. And then the reprocessing occurs, and we can monitor that. And then we have this DOI, the affected DOIs get automatically listed based on the changes. But if they're not automatically listed, if it's some kind of trigger that is not automated in our system yet, we can manually add the DOIs that are affected ourselves as well. Next slide. So here's just a screenshot of our ability to monitor the reprocessing as it occurs. So just file by file, we can see that as it progresses, and if there's any issues along the way. If there are issues, we can deal with that either by restarting the batch or whatever we need to do. But hopefully everything goes smoothly in this. And then next slide. And so this is just a screenshot of after. So now this gap is filled, and we have a complete data set. And now we also have a new DOI minted, and that information is now on the landing page. So this only affected the derived data. It didn't affect the raw data. And so that's something we like trying to illustrate when we're talking about in the reasons. Next slide. So pass it on to Chantal again, I think.
Thanks, Raina. So we've documented for users how the landing page works and a little bit more about Minted. It's accessible through the landing page itself, through the About, and it opens in a new tab completely, so it doesn't impede the user from continuing to look at that record while they look at the documentation. It includes information like what is a data citation, what are the benefits of Minted, includes some information about the web services that Melissa spoke about, as well about future work that we plan to leverage from after the project had ended. So this is an example of a way to navigate to the landing page, and I think is probably one of the more popular ways people will be interacting with the system. So through data search, you select a location and then an instrument, and there's a little details button here. When you open that, it opens to the device listing page, which Melissa had mentioned includes more metadata that's involved in the instrument than is available on the landing page. You navigate to sites. In the site tab, there's site device ID. A site device ID is a unique identifier within our system that we use to mint those particular deployments. So when you open that to a new page, a DOI is listed in association with that identifier, and that resolves directly to the landing page. So we do plan to improve the usability of this. We understand that it's not optimal, but currently that's what's in place. Oh, I should mention as well, there are other ways to do this, but this was the easiest way, I think. So Ocean Networks Canada has many data partners who deserve to be properly attributed to the data they are responsible for collecting, either with ONC or independently. And documentation is available on our external wiki, just like the user documentation. And we provide this to all of our data partners to ensure they understand how they will be credited and attributed in the ISO records, the roles in our system, the Research Organization Registry, metrics, etc. So ONC has minted 321 DOIs so far throughout the process of this project and after its completion. But after the automation process is implemented, we will have thousands of metadata records registered. Additionally, we're in discussion with Make Data Count project about metrics for data usage. They are in the process of identifying what types of metrics would be most relevant tracking data. The challenge with metrics is the meaning or impact of these numbers compared to the other data metrics collected by other like-minded repositories. We are following the community conversation so that we're apprised of any developments and so that we can implement appropriate for ONC. We are all about collecting meaningful metrics, not metrics for the sake of metrics. Other metrics that are available through ONC are involved with the query Pids, how many downloads and the subsets we offer, and the user engagement officer also tracks the traffic to our website. The PID graph is another way Minted will be using metrics to measure impacts, which I'll talk about now. The PID graph is an output courtesy of the Freya project, which I'll talk about a little bit more in a second. It connects and integrates PID systems, creating relationships across a network of persistent identifiers and serving as a basis of new services. It aggregates all citations from a research object, so the publication, the data set, the author's institution, software, samples, etc. So the image on top, A is the different versions of software code, B, the data set hosted by a particular repository, C, all digital objects connected to a research object. But as you can see, these are all the same web. They're just identifying the particular points of it. So the image at the bottom is previously, we were only being able to make connections between A and B and C, but now the PID graph enables us to make connections directly from A to C, which is quite valuable in this community. So as Melissa put it, it's 6 degrees of Kevin Bacon for science. So like I said, I talked a little bit about Freya. This project follows on two previous European Union funded projects, the ORCID and DataCite Interoperability Network, ODIN, and Technical and Human Infrastructure for Open Research, THOR. These iterative projects have made great impacts on propelling the persistent identifier infrastructures and community forward. Freya in particular has 3 pillars: the PID graph, which we just spoke about, connects and integrates systems. The PID forum promotes engagement with the global community, which will, and the PIDforum.org will be maintained by the National Institute of Standards and Technology when this project ends. And the PID Commons addresses the sustainability of the infrastructure. So the Minted project included a particular piece where we were required a representative with Freya, and we continue to use the resources that they provide. So over to Reina.
Thanks. And so what we've implemented so far is just the start. We recognize that there's still actually quite a bit of improvements and extensions that we can do. So for one thing, we definitely need to make the identifier system a little bit more exposed to the end users so that they can more easily identify the citation information that they need, and then augment that with our improved data policy, which is still pending. But of course, there's other developments that we'd like to take advantage of, introducing schema.org into those landing pages. We'd still like to come back to the ORCID for our researchers. That's certainly something our staff scientists would like for our extended science community that we support. We know that we definitely need to have something in terms of metrics automated in our system. But so Make Data Count is maybe a possibility, but the PID graph also offers some options, and like Chantal was mentioning. And one thing I really like to do is to improve the way we're communicating the provenance and representing the provenance with using the W3C Prov-O. I'd also like to introduce not only that for the versioning, but also for detailing out the processing pipeline that went into the original version. And so this is something that we still need to work on at ONC, but it's definitely one of our major areas that we're interested in. We also would like to make sure that we are linking the publications that we know of right in the DataCite metadata. This is something we're not doing yet, and so that's something we'd like to add in. And then there's one data type actually from all the heterogeneous types that we have that we're actually not supporting quite yet, and that's because it was a development that was occurring alongside at the same time as our infrastructure for Minted. So this is for a program we have called Community Fishers, where communities or partners go out and take CTD casts, so these are connectivity, temperature, depth casts, profiles in the water column, and ingest that into our system. So we have a general concept of how we'd like to do that, but we still need to implement that because that code was still maturing and nearly kind of ready for us to start on that. And so there's many directions we'd like to go here. Definitely improving the performance, maybe in some of aspects of what we offer. So it's really just the beginning, and we're still rolling out the DOIs on some of our data sets and introducing some of these geospatial areas on some of our remote sensing instruments. But the good thing is we have this great infrastructure in place, and so we're able to now deliver on some of these FAIR principles finally. So thank you for attending and listening to us, and we're happy to start to answer any questions.
Thanks so much, everyone. That was a really in-depth presentation, no pun intended. A lot of great information, a lot of great work being done. I am mindful that we are getting close to the top of the hour, or I guess close to the half hour if you're in Newfoundland. Well, we will do a few questions. I know that Melissa's been in the back end busily answering a number of them. And for the team, is it okay if we have some more of the technical questions that we don't get to? Is it okay if I send them to you to answer offline and then I can send them out to the group?
It's certainly fine with me.
Definitely. Great.
Okay, so we'll answer a few of the questions here. Maybe we'll get to all of them, hopefully. One that has been upvoted from Mark Parsons is, do you have data that crosses the pole? If so, how do you handle the bounding box?
Well, fortunately, we don't. So we don't have to deal with that case. So that, yeah, is not an edge case we've had to encounter. So I haven't thought about that. And yeah, because we don't have it. We are getting closer and closer to the poles with our Arctic data. And we are actually, we were supposed to be doing an installation in the Antarctica in January, but due to COVID related reasons, that's looking like it's postponed until 2022. But as we get closer, maybe we'll have to start to think about that.
Yeah, fun things to have on the horizon of we need to worry about this sometime. Yeah. A question from Kevin. Kevin, thanks for all your great questions. How do you share data with NOAA? Noaa.
Well, we don't necessarily, well, actually we do share data in some ways with Noaa, not necessarily directly related to this project. We have some Noaa OER, ocean exploration and research, relationships with some of our tools and services related to the ROV dive logging and video and data streams. As well, we have some web services being used by some aspects of Noaa for bottom pressure recorder data that is being helpful for tsunami type alerts as well. We have cooperative relationships to develop digital elevation maps for some projects that we've had with influence of Noaa for sure. So, but in terms of actual data sharing, in terms of I don't know, harvesting or whatnot, that's something that we're not, I don't think, doing from Noaa, but certainly something we should think about and maybe think about more two-way exchange of our data streams for whatever purposes it would be useful for. Yeah. We're definitely open to learning more what would be helpful.
Great. And another one from Kevin. How do you ensure that your data sets meet all 4 requirements of FAIR?
Well, we're working our way through and we're paying attention to a lot of the developments that are happening out in the broader community. So right now we don't have, say, like an automated fair checker on, say, our metadata record or a data set. Like I've seen at some institutions, and we've looked at some of these fair compliance checkers and are thinking about integrating them maybe into our ISO record or something along those lines. So right now we're just kind of doing it in the way of, you know, being cognizant about the principles and making sure that we're thinking about that with the comprehensive metadata, with the identifiers, trying to have as much provenance and information as we can. But yeah, I'd like to get to the point where we can actually do some kind of automated metrics on that for our metadata and our data sets, but we're not quite there. We are keeping in mind things like with our data products that we're not just serving, say, proprietary data products, that we're making sure that we have non-proprietary products, say like just CSVs or NetCDF or that kind of a thing. But and so, yeah, we're very mindful about all that. But yeah, I'd like to get to the point where we're kind of automating these checks and being able to like attach numbers and seeing how well we're doing.
Great, thank you. Can you please discuss more about your versioning process for dynamic data for a specific site? E.g., if you had data for 2017 and then later added 2018 and 2019 to the same site.
Okay, I'll try and put that into perspective. So let's say we have a site. I'll just say we have our Saanich Inlet platform underwater. And what we do is have regular maintenance on those platforms where we swap out instruments and, you know, so that the other instrument can get recalibrated or cleaned or whatever needs to happen. And so if you recall that our data granularity decision was this idea of one deployment equals one data set. So when we have that swap of an instrument, basically one data set ends and one would begin, even if it's the same device category. We're looking to the notion of collections where we could maybe like represent all that time series of that series of deployments as a collection to which could also have its own DOI to streamline both the citability of that collection. And actually we have that kind of infrastructure built into Oceans 2.0 in terms of allowing users to access the data that way, but we just don't have that concept of collection in the terms of like a DOI association. So that's another place where that RDA data granularity working group will really be helpful, because to be exploring the best practices around collections and data granularity of data sets. But so basically you have that kind of termination of the data set at that point. Now, but if we still had to version the data, like we needed to reprocess the data, it just kind of follows that process. Like I said, it doesn't matter if the data set's in the past or if it's like the current one. We just go through that, the batch process. And within a batch, you can actually affect more than one data set at a time. So if we did need to, if one fix actually affected more than one data set, you could do that all in one batch, and then you could do it all together. You don't have to have one batch per data set. I'm not sure if that answered the question really well.
Well, this actually gets into some another question from Daniel, which is, can queries contain data from multiple resources or data sets, like from two different sensors? And then how would a user cite that? Which sounds kind of like the collection that you were talking about.
Yeah, it's partly, there's two aspects to that. So when I saw that question, so the idea was like, what if you had two sensors? So basically for us, a data set is a deployment, but within a deployment you have one device. So within that you have multiple products and sensors that are all pertaining to that particular device and deployment. So if a user selects data from, say, both sensors, it's still within that data set. It's just the way you define the query is different than one sensor. So that query metadata, which shows up on that right-hand side of the landing page, would specify both sensors as opposed to just one sensor. And then the other idea is, what if you were actually asking for data that does span a longer time period? So in our data search, you can actually query for data that's spanning more than one deployment. So in that case, now you're actually getting into the realm of you need to have more than one DOI for each data set. So you have basically a list of DOI query PID combinations for that whole duration. Now, that's not obviously that nice and tidy for someone actually trying to cite the data, and we recognize that. So that is definitely where we want to utilize this notion of the collection to simplify. But yeah, we just haven't been able, we want to be careful about how we go about that, because recognizing the permanence and this, the long-term access to that information needs to be upkept. So we're just really trying to think about that process very carefully, but that's something we definitely know we need to account for. If that answered that question.
Yeah, I think so. Yeah. And Daniel says yes. So, so I think we'll end on this question that's been upvoted. And as I said, the questions that we haven't answered, I will send to the team to get answers for, that I can send out to all of you when I send out the link to the slides and the video, etc. But this is a good question to end on, I think, from Krisha out at McMaster. How can the system that you've developed and the lessons learned be shared with others to emulate besides this webinar? Is the development or application open source, and can it be adopted by other disciplines or organizations?
Yeah, this is definitely something we want to do more of. So this webinar is hopefully just a start of trying to communicate and disseminate that information. So we do hope to come up with some kind of publication or yeah, basically some kind of documentation that can be made public. I don't know if it'll be in the form of like a white paper, or if it's something we submit to Ocean Best Practices, or just have available on our public wiki. I'm not sure yet, so we have to figure out what form that takes still. But we definitely want to disseminate that, and we're going to be trying to look for like other opportunities that we can to help, especially as we mature and figure out more of the problems that remain. But certainly it's definitely something that's on our mind. Our code is not open source though at this point, but in terms of well, it's difficult to make it so in terms of a way that another organization could easily digest, because it's so integrated across a huge digital infrastructure with, you know, a lot of different modules going on. So it's not something that's easily extractable for another organization, but certainly conceptually, maybe like from an architecture, like a simplified diagram point of view, we could make that more accessible. But I don't think the code itself is really something that would really be helpful to anyone that's not Ocean North Canada, unfortunately.
Maybe down the road, we'll see.
But certainly
right now,
conceptually, there's a whole lot of hurdles that we've gone through that I think are more broadly applicable, especially to like other kinds of like sensor data stream type systems.
Great, thanks. Great, and Kevin, I think I'll ask the team to send out some examples of PID graphs with Ocean Canada data, because I think that will be easier to send as something you can look at offline. But again, thanks for that question. Thank you, all of you, Raina and Chantal and Melissa. That was a wonderful presentation. As I said, lots of information, lots of things to think about. And thanks to all of our attendees today for coming and for participating and asking such great questions. A reminder that we have our last webinar with Global Water Futures tomorrow, which is an introduction to the Compute Canada Federation. And next week at this time, we'll be having a presentation from UBC on building RDM across an institution. And I will be sending out the slides, the link to the video, and any remaining questions to be answered for this webinar in just a couple of days. So stay tuned for that. And again, thank you to everyone, and have a great rest of your Tuesday.